This is our video lesson for Unit 4, Lesson 3. The goal for today's lesson is if I'm given a function rule, I can represent the function as a table and a graph. And I can identify important characteristics about the graph of a function. So let's take a look at our first example. They give us our function rule, g of x equals 2x plus 3. And they want us to fill in the table for the inputs that are given. So I'm going to start with an x value of -3. To evaluate that, I'm going to plug -3 into my table. 2 times -3 is -6. So I guess I think maybe, let me make this a little bigger. Okay, that should help. So now I'm going to do 2 times -3 plus 3. That would be -6 plus 3. And -6 plus 3 is -3. So that gives me my first point on my graph, which is -3, -3. So there's the first point of my function. My next one is to plug in an x value of -2. So I'm going to do 2 times -2 plus 3. That's -4 plus 3, which is -1. So my next point is -2. So I go backwards 2, down 1. Next x value it asks me to plug in is -1. So 2 times -1 plus 3, -2 plus 3, and that's 1. So I get -1, 1. Then it wants me to plug in 0. 2 times 0 plus 3, that's 0 plus 3, which is just 3. Then it wants me to plug 1 in. 2 times 1 plus 3, that's 2 plus 3, which is 5. There's my next point. Next one is 2, so 2 times 2 plus 3. 4 plus 3 is 7, so 2, 7. And then my last one is 3. 2 times 3 plus 3, that's 6 plus 3, which is 9. And now I can go ahead and connect those. Do not forget to sign the line. I'm going to label this g of x equals 2x plus 3. So I've drawn my graph, I've filled in my table. It says name the type of function. Well, the type of function, this formed a line. So this is a linear function. And if you've forgotten the types of functions, the names of them, that is in lesson 2 on the first couple pages. And then it asks, what is the domain and the range? The domain is your x values. So we're thinking left to right. So if I look at this function, if I go along my x-axis, left to right, the question is, like, if I'm out here at -10, am I going to eventually hit a point on the graph? I think because this continues, I will. What if I'm out here at -20? Will I eventually hit a point on the graph? Yes. So my graph goes to the left forever and ever. This arrow is going to keep going to the left and down. This arrow on the right is going to keep going to the right and up. If I was out here at 100 and I traced up my graph, would I eventually hit my line and get an output? I would. So the domain of my function is -infinity to infinity. Or the other way you can write that is if you draw two lines close together and then draw a capital letter R through them, that stands for all real numbers. This graph exists. I can plug any X value into it and get an output. The range is your Y values. And for your Y values, you want to think bottom to top. What's the lowest this function goes and what's the highest it goes? Well, on the left, this arrow is pointing down. It's going to keep going down forever and ever. So if I get to a Y value of like -12, there eventually will be a point on my line that hits that. So my range, since my function goes down forever and ever, is going to start at -infinity. And then if I look up, it keeps going up forever and ever. So if I eventually wanted to know when I'll have a Y value of 100, I'm going to have to look over pretty far on my graph, but eventually it will get to 100 because it keeps going up forever and ever. So my range would be -infinity to infinity, or you could write it as all real numbers. Now, if you don't have a calculator, please make sure you get one out, because for the next function, we're going to do the first couple points by hand, and then we're going to use the calculator to help us. Okay, so they give me the function rule y equals 2 to the x power, and they want us to make a table and a graph of this function. For my table, I usually like to put 0 in the middle if I can, and then do a couple negative points and a couple positive points. So now I'm going to go to my calculator. I'm going to turn it on. I'm going to open a new document, and I'm going to add a graph page. So the function rule that they give me is y equals 2 to the x power. So to type that in, I'm going to type in 2. To get an exponent, you hit this caret button right here, to the x power. And if I hit enter, I can see what that graph looks like. Now, if you did not get that graph, please make sure you ask someone around you or ask me what happened, or even better, rewind the video and follow along and see if you can get this function. If I want to know the values of the function, if you click Control followed by the letter T, you'll get a table. And I'm going to go ahead and scroll up and find my points. So I can see here that at -2, my function has an output of positive 0.25. At -1, it's 0.5. At 0, it's 1. At 1, it's 2. And at 2, it's 4. So now I can go ahead and plot these points. So at -2, it's at 0.25. -1, it's at 0.5. 0, it's at 1. 1, it's at 2. 2, it's at 4. And I could keep going if I wanted. So if I scroll down at 3, it's at 8. Now, I notice that my function comes down this way, and then it just lays along the x-axis. So this function, what's happening here is the function gets closer and closer to 0. And we can see that on our table if we scroll backwards here. You can see all these numbers are getting closer and closer to 0. Now, when you get to this spot, that e to the -7 means that I've got a 9.5, 3, 6, 7, and the decimal is moved 7 places to the left. That's what that -7 means. So that's a number really close to 0. The next thing it asks is to name the type of function. When your exponent is a variable, this is called an exponential function. And we are going to study this after we complete this unit. Exponential functions, they grow really slow at first and then they take off. Next thing it wants to know, what is the domain? Remember, domain means I want to look left to right. And these are your x values. So as I go along my x-axis, I can see my function goes to the left forever and ever. And then if I keep going to the right, if I go back here in my calculator, if I keep moving to the right, this keeps getting bigger and bigger and bigger. Okay, so that means as I keep going to the right, I'm still going to have outputs for my function. So it goes from -infinity to infinity. My range is my y values. So this is bottom to top. So when I look at my function, it does have a distinct lowest point. It doesn't ever go below a y value of 0. In fact, we said it gets closer and closer to 0, but it never hits it. So my range is going to be, it starts at 0, but I'm using a parenthesis because it never actually gets to 0. And then it goes up forever and ever and ever. So it's going to go to infinity. Okay. Just a really, really quick one more example of a domain and range, just so you can see this. Let's say I had a function that looks like this. And this point right here is -2. So my domain is left to right. If I look, this function goes on to the left forever and ever. It's going to keep going to the left, keeps going to the right forever and ever. So my domain is all real numbers or -infinity to infinity. My range is bottom to top. Well, the bottom of this function keeps going down forever and ever. These lines are going to keep going and going and going. So there really is no bottom to this function. It goes to -infinity. However, it does have a top value. The highest this function gets is -2, and it equals -2 because there's a point at -2. So this would include a square bracket. Were that we could, at least for this lesson, given a function rule, we could represent it as a table. So we did that here. We were able to plug in our x values and get our y values. Our next goal was that we could identify important characteristics about the graph. We were able to identify the type of function and domain and range. So hopefully this helped you with how to graph some functions, and we'll keep practicing in class. Thanks.